Alright, number 141, linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached, again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So basically, my idea here is while next then we just shallow copy each node into a set which we can just call visited. If val in visited turn true, if it's not a cycle, it will eventually break out of this while next, just because we'll hit a next that is equal to none, and then when that happens we will return false. And I think that's the plan. If we just shallow copy in, a shallow copy is like the same instance of the nodes, so we don't need to it'll be fine if we just add it to the set. So if we just have a visited set like this, then we do while head dot next, I think. Do we want to do while head dot next, or do we want to do while head dot val? No, while head dot next does not equal none. This is the same thing, but it's going to get to the last node, I think. We'll just try. If head dot val in visited return true, else visited dot add head dot val, and then what do we need to do? We need to set head as equal to head dot next, and then we return false. Head is equal to head dot next, visited dot add head dot val, and let's see, we might have to just add head, not head dot val. But I think that should be fine. Oh, it probably won't be fine. Yeah. We need to add head, not head dot val. If head in visited. Three out of 29. None type object has no attribute next. Okay. If head equals this, what do they want us to return here? Presumably false. I don't understand. I don't know what output it's looking for here. Cool. So it looks like just adding it to the set, adding the actual head to the set works. This isn't a very fast answer, so I might take a look at some quicker ones. Initially, my idea was to actually just override the list node and add a boolean variable, but I don't think that's allowed. So it looks like these guys are using the fast pointer, slow pointer method, like the tortoise and the hare algorithm. I actually haven't learnt how this one works yet, and to me, right now, it just looks like a bit of magic. But that is definitely something that I will be figuring out in the near future once I've done a bit more on backtracking and get that a bit more under under control, I guess. But yeah, awesome.